All right. Let's do this. We are solving the bank robbers puzzle on CodeandGame.com. It's supposed to be an easy puzzle to solve, but we'll see about that. What we're going to learn: loops and mathematics. Ooh, exciting. All right, what's the goal? A gang of foolish robbers decides to heist a bank. In the bank, there are V vaults indexed from 0 to V minus 1. The robbers have managed to extract some information from the bank's director. The combination of a vault is composed of C characters, digits, or vowels. Okay. The first N characters consist of digits from 0 to 9. The remaining characters consist of vowels A, E, I, O, U. C and N may be the same or different for different vaults. Okay. Let me just unpack this. The combination of a vault is composed of C characters. So C characters, that's the amount of characters. The first N characters consist of digits from 0 to 9. The remaining characters consist... Okay. I getcha. C and N may be the same or different for different vaults. All right. All the robbers work at the same time. A robber can work on one vault at a time, and a vault can be worked on by only one robber. Robbers deal with the different vaults in increasing order. A robber tries the combinations at the speed of one combination per second. He tries all the possible combinations, i.e. he continues to try the untried combinations even after he has found the correct combination. Once he finishes one vault, he moves on to the next available vault. That is the vault with the smallest index among all the vaults that have not been worked on yet. The heist is finished when the robbers have worked on all the vaults. Assume it takes no time to move from one vault to another. You have to output the total time the heist takes. Oh wow, that's interesting. That is interesting. Alright, let's get to work. Let's just set this up here for my external editor. We want to use... I've set this up already. Bank robbers. Nope. I have to do this. Run my dev thing, which will build our TypeScript into JavaScript, and then I can select this here. Bank robbers, we're good. Upload from local file to code and game. We're all set. Okay, I can get rid of this and that. And as always, I need to tell TypeScript about the readline function, which is a built-in code and game engine function. So function readline, which outputs readline, which outputs a string. Okay. So what are we doing here? We're parsing R. Getting our, oh, actually, let's take a look at this here. This we've just read. Okay, our inputs. The first line we're getting is the R, the number of robbers. Second line we're getting is the number of vaults, which will never be more than 20, and there's never going to be more than 5 robbers at a time. Okay. The next V line, so the next amount of vaults lines. For each vault, one line of 2 space separated integers, C and N, for the total number of characters, C and the total number of digits n in the vaults combination. The vaults are ordered by their index. Okay, so 1, that's the number of robbers. This is the number of vaults. This here, C, is the number of characters in the combination. 1, N, is the total number of digits. Yeah, the first N characters consist of digits from 0 to 9. Okay, so we're looking at combinatorial stuff here. Yeah, now I know why they're saying we're going to learn about math. It's all buried deep in my brain, but let's see if we can recall some of that stuff. And we get to 250 being the amount of seconds it takes, and we know that we're trying one combination at the speed. We're trying all combination at the speed of one combination per second. Right. He tries all the possible combinations. He continues to try the untried combinations even after he has found the correct combination. Once he finishes one vault, he moves on to the next available vault. That is the vault with the smallest index among all the vaults that have not been worked on yet. The heist is finished when the robbers have worked on all the vaults. And the robbers can work at the same time, but not on the same vault. The robbers can work on one vault at a time. Any vault can be worked on by only one robber. Robbers deal with the different vaults in increasing order. I don't see what difference that makes. Right. Does it make a difference? Oh, it does make a difference because they're not all the same size in terms of their combinations. Okay. How are we gonna do this? How are we going to do this? So that's the amount of robbers, that's the amount of vaults. This here is basically one vault parameter, C and N. Yeah, I'm going to have to. Now I know there's a formula to calculate the amount of possible combinations given, let's see here. Let me get my little friend paint thing. So given a certain amount of, let's see, digits or characters, and we know that each character can be a certain amount of combinations. How do we calculate the total amount of combinations, right? And I think it's usually as simple as saying, let's say there's 6 of them, and it can either be a 1 or a 0, let's say. In other words, 2. Then I think it's just a matter of going 2 times 2 times 2 times 2. You get the idea, right? I think it's that simple, and that will get us to the answer we're trying to get. But in our case, we are trying to find, is there a way to erase this like that? I guess. Nope. Oh, just delete it. There we go. Okay. Now the thing here is that what we're given is a problem where this here will be a certain combination of, let's see, let's get back to our problem here. Right, vowels, 1, 2, 3, 4, 5 vowels. Right, so 5 vowels. And the front will be the first n characters consists of digits from 0 to 9. So in other words, 10. So, is it as simple as going 10 times 10 times 10 times 5 times 5 times 5? It might be. It might be. I think it might be. But first of all, let's just confirm that I've got the base formula right. How to determine amount or number, yeah, let's go with number of combinations. Let's just try that. To calculate combinations, we use the formula. How to calculate probability of combinations? No, we're not looking at probability. Combinations, permutator, easy permutations and combinations. How to calculate probability of combinations. Permutations and combinations from, yeah, I think that's, let's try this here. Before we discuss permutations, we're going to take a look at the word combination means and permutation. Doesn't matter in what order we add our ingredients, but if we add a combination to our padlock, that is 5, 4, 5, 6, then the order is extremely important. If the order doesn't matter, then we have a combination. If the order do matter, then we have a permutation. One could say that a permutation is an ordered combination. The number of permutations of n objects taken R at a time is determined by the following formula. P and R n factor of n. What? Code have 4 digits in specific order. The digits are between 0 and 9. How many different permutations are there if one digit may only be used once? That's not the case. That's not our case here. So we are looking not at permutations, but at combinations. So get us the combination stuff. Nope. I just want combinations. Come on. Combination formula? That looks like the same thing. I think I remember watching this on Khan Academy at some point in my life.
The first time you're exposed to permutations and combinations, it takes a little bit to get your brain around it. So I think it never hurts to do. You know, we could do it. You know, well, I'll apply the formula first, and then I'll reason through it. And like I always say, I'm not a huge K things in K spots. 4 factors of 6 factorial. So if you want, and that's where the 4 came from. We wanted the first 4 factors, and so the way we got 2 is who we put here, because it takes a little bit to get your brain around it. So I think it never hurts to do as many examples. But each incremental example, I'm going to review what we've done before, but hopefully go a little bit further. So let's just take another example, and this is in the same vein. And in the next in videos after this, I'll start using other examples other than just people sitting in chairs. But let's stick with it for now. So let's say we have 6 people again. So person A, B, C, D, E, and F. So we have 6 people. And now let's put them into 4 chairs. We can go through this fairly quickly. 1, 2, 3.
Oh, buffering. I wonder if that's because I'm streaming stuff on Twitch. I don't think so.
On permutations that, or when we talk about the permutation formula, one way to write this, if we wanted to write it in terms of factorial, we could write this as 6 factorial, which is going to be equal to 6 times 5 times 4 times 3 times 2 times 1. But we want to get rid of the 2 times 1. So we're going to divide that. Now what's 2 times 1? Well, 2 times 1 is 2 factorial, and where did we get that?
I think that's for permutations. We're looking at combinations. Just, it could be any of... number of combinations. Combination is an unordered series of distinct elements. Yes. An ordered series of distinct elements is referred to as permutation. No. A salad may contain lettuce, tomatoes, and olives. It does not matter what order it's in. You say lettuce, olives, and tomatoes, or olive, lettuce, and tomatoes. In the end, it's still the same salad. This is a combination. The combination to a padlock, however, must be exact. Is that okay? Well, combination is 40, 30, 13, then 30, 40, 13 will not open. Yeah, okay. This is known as a permutation. Oh, I'm all mixed up now. Which one is it? Which one is it? That's it? No more than that? Ugh. All this math stuff. Ugh. I might just have to actually listen or read the whole thing if I want to get this right. We throw around the term combination loosely and usually the wrong way. We say things like, hey, what's your locker combination? But what we really ought to be saying is, hey, what's your locker permutation? Okay. The permutations of 2, 3, 4, 5 are... Okay, so we're not looking at permutations. Because we can have more than one 5, or we can have more than one 4, or we can... The multiplication principle, permutations with repetition. Oh. What if I wanted to find the total number of permutations involving the numbers 2, 3, 4, and 5, but want to include ordering such as 5, 5, 5, 5, or 2, 2, 3, 4, where not all the numbers are used, and some are used more than once? Oh, that might be exactly what we're looking at. This turns out to be a simple calculation. Again, we are composing a 4-digit number, so draw 4 lines. In the first position, we have 4 number options. Yeah, that's what I was doing. 4 times 4 times 4 times 4. Yes. Okay. Choosing a subset. Let's up the ante with more challenging problem. How many different 5-card hands can be made from a standard deck of cards? In this problem, the order is irrelevant since it doesn't matter what order we select the cards. We'll begin with 5 lines to represent our 5-card hands. 5-card hand. Assuming no one else is, oh yeah, so, yep. If we have n objects and we want to choose from k of them, we can find the total number of combinations by using the following formula. That doesn't. Anyways, This here is what I'm getting from this. Or here. It's as simple as multiplying for each space the number of options. So I think I'm not wrong when I say that it's as simple as going, for each possible our D variable here that we, let me pull that up again. Where was it? Oh, here. Not D, what is it? C? No, C is the total combination. N, okay. N is the total number of digits that we have at the start of our combination. And we know that it's always from 0 to 9, so 10 options. So I think, yeah, whatever our N number is, so we go 10 times 10 times 10 times 10 for N times, and then we just go for the rest of our C combination, 5 times 5 times 5, which is the amount of the vowels that we have. Okay, I think we have a plan here. And this here will be our, this represents 1 volt. So maybe we can store that information somewhere. Store, let's call that volts. We'll make that an array. And we'll simply push volts dot push. Let's just make that some sort of an object that has a C property and a N property. Simple as that. Okay. So once we're done with that, we can let's see. If we only have the 1 robber, we have to go in order. So we start with volt. So that'll be a for loop, right? For const volt of volts. And what do? We basically have to determine the number of combinations. That's all we need to do. Determine the number of combinations. And we've determined that we did that. Well, maybe I should have taken a look at that formula. It'll be easier to use that formula then. This is the same as saying how many different ways can I arrange 5 cards. That's 311 million something permutations. That's permutations, not combinations. To fix this, we need to divide by the number of hands that are different permutations but the same combination. This is the same as well, in this problem, the order is irrelevant since it doesn't matter what order we select the cards. We'll begin with 5 to represent our 5 card hand. Assuming no one else is drawing cards from the deck, there are 52 cards available in the first draw, so place 52 in the first bank. Once you choose a card, there will be 1 less card available on the next draw, so the next one will be 51, and so on. That's permutations, not combinations. To fix this, we need to divide by the number of hands that are different permutations but the same combination. No, we're actually interested in the different. We're interested in all. Okay, so a combination, I get it. A combination is in any order a given set of cards. A permutation is just one specific order for a set of cards. So we're looking for the permutations, and that is as simple as just multiplying. So let's just do that then. There's probably a nice little formula. Oh, well, there is. Here it is, permutations formula. The formula for permutation is similar for the combination formula, except we needn't divide out the permutation. So we can we can remove k this from the denominator. What the heck is this? I remember it means factor of, is that what it means? The exclamation mark. And well, they weren't kidding when they said you would learn math by doing this. Okay, it's all so far away in my mind, so math.com. Meaning of exclamation mark in math. Symbol represents the factorial operation. Yeah. So for the exclamation point. It denotes the factorial operation. Factorial is a positive integer. Denotes by n integer. So 5 means 5 times 4 times 2. Oh, okay. Is the product of all positive integers less than or equal to n, for example, the value. Okay. So permutations of n, k. What's n and what's k in here? If we have n objects and we want to choose k of them, we can find the total number of combinations by using the following formula. Factorials of n divided by, we want to choose k of them. Oh, so I'm guessing k factorial n minus k. We have 52 cards, okay. And want to know how many 5-card hands we can make. Plugging in the values, we get 52, 5, 52 factorial, 5 factorial minus 52, okay. Which is exactly what we found, so. P would be, and so we just need to go, okay, I think I get this. I think I got this. Let's just put that on the side here. And let's put that on the side too. So, if I was to go and say, what's our wait, a minute. Well, the problem is in the fact that we have to split the thing in the middle. How am I going to deal with this? Well, I could do the formula on both sides and then do a global formula for the amount of... Would that work? It would. It would work. So let's start with dealing with our n number of n. Well, that's actually just n. Okay, so I don't need to do that. So let's build it with just n then. I should have some, let's see, const number of possible digits. Let's make that a real const. So, number, I'll just call it number of digits. Equals 10, and const number of vowels equals 5. Okay, so now what we're doing is we're taking the, I wonder if there's something in the language for factorials. I doubt it, but let's look it up. Just in case, or otherwise I'm going to have to implement that myself. JavaScript, factorial. There are ways to factorialize a number in JavaScript. In mathematics, the factorial of a non-negative integer n can be a tricky algorithm. In this article, I'm going to explain 3 approaches. Yeah, that's what we're looking for. What is factorializing a number all about? 5, why would you? Well, if I need to do all this computation to get the, I might as well just do it that way. So that's what we're going to do. So what we first need to do is for whatever amount of n's, let's just get back to our little formula here. Really isn't that complicated. We're simply doing n to the power of, I think this is, there's a few ways to do this in JavaScript. JavaScript, power, math. There's math.pow, okay. Let's take a look at that. There's 7 to the power 3. Okay, so this would work, but I think there's a exponentiation operator in JavaScript. Let's take a look at that. One of the features that's very likely to make it into this release is the exponentiation operator. As of today, it's a state 3, so that's old stuff. I think it has been implemented. I seem to recall, and it is the 2 asterisks, right? Let's try that right in here. Kicks. So math dot pow of 5 to the power of 12, say. And we get this crazy ass number. Okay. 24 something 1406 blah 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 blah. Okay. If we do 5, boom boom, 12, there we go. Okay. This works. So why don't we use that? N to the power of how many options? Oh wait, is it the amount of options by the power? Which one is it? Yeah, I think it's the number by the amount of options, and our options are number of digits. In this case here, number of digits. And cannot find name n. How can you not find the name n? It's right here. Oh, sorry. There we go. Okay. So that takes care of that. And then we need to times this by I believe vault dot c minus vault dot n. Just put that in parentheses here so that to the power of number of vowels. So that's really clear what's going on here. Here. Wait, there's no confusion. Okay. And that's our amount of combinations, or permutations, should I say, permutations. And in our first test case, there's only one, so we could just, let's see, permutations equals 0, and then we'll just assign this here, and it's got to be a let. And let's just print that, see what happens. Permutations. Let's see how badly that blows up in our face. Okay, okay. Very close. We're expecting 250 and we're saying 32. So, where's the problem? Problem is most likely here. What if I do power of? I don't think that makes any sense, but I'm just curious what that's going to give. Math by trial and error. Well, found one. That doesn't make any sense. How do I end up with one? Okay. The other way is to use like yet more loops and go something like for let actually this is going to be a for loop with let I equals vault dot n, and then keep going as long as I is bigger than 0, and you just decrement I. That's probably better to do this instead. Start with 0, keep going as long as I is smaller than vault, start with 1, it's not 0 indexed, as long as vault dot n and equal vault dot n. I could just do like that and just do the smaller vault dot n I plus plus, and then what do we do for each for each possible character that's going to be a digit? We need some sort of accumulator here. Let sum, we'll just call it sum for now anyways. Actually no, this needs to start with number of digits. Number of digits. And what we're going to do is wonder if, no, let's just do it that way. Okay. So we're starting with that. Start this as 1. We are going to go sum times equal number of digits. Okay. And once we're done with that, essentially do the same thing with this time vault dot c minus vault dot n, and here is number of vowels. Okay, that's our sum, and once we're done doing all that, our permutation is going to be equal to the sum. Not really a sum, but whatever. Understand for now, let's just test that. Yeah, our math is not there. Something doesn't add up. This is all caca. Hmm. So that's the amount of permutations. 10. So in our case, it would be 10 times 10 times 10 times 10. Wait, this should have worked. This should have worked. Unless maybe. Oh. I think this might have been it. Aha! Yes. Okay. So, if at home you're wondering what the problem was, it's simply because for this one here, I'm starting at 1 because I'm already starting with our value here, and then I'm going times this, and then times this, and then times this. But when we're skipping over to the other side of our combination, right, our log combination, we already have the running total that we need. So, yeah. All right, so this works. Now, let's try the other one. More robbers, more vaults. Interesting. Should be solved by doing simply plus equals. This still works. This, oh. Interesting. Interesting. Why? Why are we? Oh, because they're working at the same time, right? More robbers, more vaults. We've got ourselves 4 robbers and 4 vaults. And they get to work at the same time. Now this is where it gets interesting. This was the easy part. Let's turn that into a function that we're going to call get combinations. Yep. And all you need to do is pass in a vault. That's right. Perfect. Okay. So now, oh, and actually here, we're going to return some return. We're going to call this total. It's not really a sum. Technically, I don't think so. Now, what do we need to do? This won't work here. Won't be that simple. I don't think so. We'll see. Let's see. Okay. So we first need to get the combinations for each vault. The number of combinations for each vault. So that's what we're doing here, but we need to push that somewhere. So actually, this can be quite easy. Let's do vaults dot map, and then we call our get combinations function. Don't even need to do more than that, right? And that should give us an array of combinations. Now, what do we? How do we deal with the fact that we have robbers working at the same time? Okay, let's just call that vaults combinations. Let's see. Well, if we have a robber working on, so I don't think we're going to need this here. Is there a math formula for this? Maybe. But just logically, how does it work? If I'm working on the first one and it takes me 1,000 seconds, and then the other robber 2, works on the second one, and it takes 800 seconds. So he'll get to start working on the second one, or the third one, and so on and so forth. I think the best way to reason about this would be for me to actually pretend that we're doing that work. So why don't we do that? So we're going to make ourselves a nice little class called robber. And our robber is going to be either at work, we're going to start off by not being at work. That's pretty much the only thing we're interested in, I guess. So let's not be stupid and just use a plain boolean. An array of booleans. For our amount of R's. So const robbers is going to be an array from new array the array length is going to be robbers if I do it that way. Go map and just shove. Let's see, what are we looking for? Just a boolean. So turn false. Simple as that. Should end up with an array of, yeah, okay. So now that we've got our robbers, what are we do with them? For not the way I'm thinking about it. I'm going to need to parallelize. So I really need to do some sort of math here. Gah. If I take 4 let's use paper here for a second. I really just need to take a chunk of R vaults, the first R vaults. And then from that, I don't know, that's not going to work. Oh, how do I do that? This was rated easy. Code in game. So let's, okay, let's do this. Let's try to, that's taken care of. At least we got that figured out. Now what we want to do is, let's say that we have 4 robbers. Which is the test case we're working on right now. 4 robbers, 4 vaults. Robbers, 4 vaults. P equals 4. So let's say the first vault had 1,000 permutations. The second one had 750. The third one had 2,500. And the fourth one had 1. So how long would it take this team of robbers to get all combinations? Well, it would just take the highest of all these because they work at the same time. Alright, so we're taking first 4, we're getting the longest one. So really that's not hard to get. Anyways, to get this test case to pass is not that hard. So how do we do that? We simply go 4. Let's just split, I guess, or where's our array? Don't we have an array? Weren't we doing, whoa, did I delete all of that? Should have deleted that, okay. So we can just take our vaults combinations, and then do a split or slice, or splice. Which one is it again? Slice. There's no split, it's slice. Returns a section of an array. Removes elements from an array, and if necessary inserts new. No, we don't want that. So let's use slice. This won't mutate our array. What do we need to pass in? Start the beginning of the specified portion of the array and the end of the specified portion of the array. But I think mdn array dot slice. I think if you don't pass in, let's see, begin is optional because otherwise it'll start at the beginning, which is what we want. End, well, I guess we'll have to put 0, and then end will be for, is it inclusive? At which to begin extraction? Yes. Okay, 0 based index before which to end extraction. Yeah, okay. It's kind of a gotcha. So we're starting at 0, and we're getting up to R, right? Because it's before, no, it's R minus, wait a sec. And extracts up to but not including end. Up to but not including end. So we're actually R minus 1. Right. No, actually that works because it's up to but not including. So we want 0 to 3. If R is 4, 0, yeah, okay. So now we've got our vaults combinations, and we want to return the biggest one, the biggest number from that. How do we do that? Well, I'm glad you asked. There's different ways to do this. We could sort it. And then compare function. What's the? I think it returns minus. We need to return -1 or +1 depending on. So it would be something like A, B, return A is smaller than B. No, bigger. We want if A is bigger than B, then yup. Array sort. Biggest to smallest would be not C#. I'm interested in about this. Totally no use to me, thank you. I'm pretty sure they have that example straight in the docs on MDN array sort.
1, 2, 3, 4.
There you go. The sort method can conveniently examples. A minus B. Right, that's all we need to do. It's not bigger, it's minus because that's right. It needs to return either a positive or a negative number, and that's how it knows what it's supposed to do. So we're doing this. And we're ending up with a sorted array, and we're interested in the first array. First number here, const seconds equals this. Just print out the seconds. Is that gonna work? Let's find out. Let's try our first one again. We didn't break anything, that's good. Second one, that didn't work because I'm not sorting the right way. I guess it should be a B minus A. There we go. How about that? Okay, fewer robbers than vaults. And this is where we need to do something. Fewer robbers than vaults. So we're left with some vaults to deal with here. Aye, this is complicated. This is complicated. So maybe I should just do splice. And I can reuse the vault combinations afterwards. So splice. Start, delete, count, which is the same thing. Removes elements from an array and if necessary inserts. No, do not insert it. New elements in their place. The zero-based location in the array from which to start removing elements to number of elements to remove. So if I were to do this, it shouldn't have changed the fact that we're passing here. Oh. And we're passing here. Why was it so long? Oh, okay. And this is still not going to pass. Okay, so now we're mutating our vaults combinations. This gets us the longest amount of time it's going to take for our Alright, so basically what we need to do is some kind of for each. No, that doesn't work. Because it gets mutated at the same time, so. Maybe a while? Yeah, let's try that. While vaults combinations dot length. And here's what you're gonna do. You're gonna take a slice out of our vaults equal to the amount of available robbers. Wow. Oh, my head is going to explode. Okay. What do we need to know? We need to know the longest vault, the one with the most combination here. And we get that. But then we need to know how much time the next set is going to take. How do we get that? Let's do that on paper again. So let's see, let's scrap all of this. Gonna have to write a little smaller. So in our case here, we've got two robbers for vaults. Two robbers for vaults. So, oops. R equals 2, vault equals 4. And again, let's say that the first vault is 750. Second one is 1,000. And the third one is 1,250. And the last one is 500. So what do we need to do? We take the first two right here. And right now what we're doing is we're getting the biggest one of the two. Right, okay. Then we can get to work on this. But in practice, what would happen? Our robber would finish after 750 seconds while the other one was still going for 250. And then he'd get to work on this one here, the first one. So we're basically doing 750 plus 1250 is how long this robber's work. Okay, maybe we need to add whatever each robber's doing. and then take whatever the longest is out of that. Now that makes a lot of sense to me. That makes a lot of sense to me. So that's exactly what we're gonna do. That is exactly what we're gonna do. So we don't need this. I don't think so. Oh wait, it's not that simple. It's not that simple because it's just not a question of kind of jumping to the next one. Right, like robber 1 here won't necessarily, in this case it is, but if these were inverted, robber 1 here would not be the one to go for this first one here. He would end up being second. So what we need to do is resolve this first one and go, okay, so this is robber 1, this is robber 2, and we'll have a variable here, robber 1, and then robber 2. And now we'll splice our array by the amount of robbers, and then we'll go, okay, robber 1 gets to be done in 750 seconds. And then robber 2 gets to be done in 1000 seconds. Then we need to check, once we're done this, we need to check, okay, who's got the smallest number here? Well, it's robber 1. Good stuff, robber 1. You get to take care of this one. And we add 1250 to your total, which now becomes 2000. And then robber 2, you get this. You're now at 1500. And we look at who's got the smallest amount of seconds. And this time around, it's robber 2. So if we add more vaults, then this time around, robber 2 would get the first vault in the array. And so on and so forth until we're done. Now I think that algorithm works. So how do we do that? Well, I think our idea of the while loop wasn't that bad. Because we need to keep going as long as we've got. So while vols combinations dot length is the length property being updated every time we splice? I believe it is. Sure hope. Let's try this. We've got an array with 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, it's got 6. We're going to call this R. Okay, and then we did R.splice. And we're just going to take away, we're starting at 0. We're going to take away 2. Boom. R.length. Yeah, that works. Okay. So this should work. As long as it's not 0, we keep looping. Now what do we do within that loop? Well, first thing we need to do is splice our array. And we splice it by the amount of R's. Now what if there's less than R's? What happens? What happens when we try to splice? Splice MDN. FW count is 0 or negative. No element are removed. In this case, you should at least the element to be added in the array. Doesn't really say, does it? Let's do a little test again. Const r equals, oh, what? R. Does it still have that in memory? No. It just remembers that I did that before. It's great. Okay. So if we do array.length, we get the 6. Okay, so let's do array.splice. And let's say we were trying to splice 12 elements. We don't have that many. It just splices whatever it has. That's cool. So now r.length is 0, and we've got oh, that's great. Okay. Don't even have to worry about that. Don't have to check for errors or any if statements or anything like that. Vault combinations.splice. Cool. Now that we have done that, we need to sort it. No, we don't. Actually, we don't want to sort it anymore. We don't want to sort it. What we need to do is we need to create an array. We need to create an array of robbers. So array from R. No, it's just new array. New array R. Yep. Okay. Do I need to do anything to that? They'll just be undefined, so let's get them a map. Simply make them zeros. Okay. I think there might be another way to do this here, but this works. A number array. Good. So now that we've got that, we've got our array, what do we want to do? For each array, we take our seconds and we're also going to need our index. Thank you. And then we go robbers index plus equal seconds. There we go. Now, once we're done with that, we need to sort our array. Robbers dot sort, and we and B, and this time we're going to sort from smallest to, which was A minus B, right? A minus B, ascending order. Okay, and then when we're done with that, we loop again. We splice another part of that array, get another set of vaults, but this time around we're assigning the seconds from this first. Yep. This works, and then when we're done all of that, we just look at our robbers. Array, and we take the last element, which will be robbers dot length -1, and that's actually what we need to console log, I think. Let's give that a try. That's a lot of changes. See if our first one works. It doesn't. Not a number. How am I, what is not a number? Huh. Where could I be running into this not a number problem? This is a number, we're assigning that to number. Robbers is a bunch of numbers. Okay, time for some debug. Let's see if this works out of the box. Okay. Exception has occurred. Reference read line is not defined. Yeah. Yes. So let's do just a simple one. 1 and 1. But I also need to put, this is gonna, yeah, I can't really use the debugger here because I'd have to well, maybe I can. Hold on. Let's just reuse some of this stuff here. 3 and 1, that's it. I think I can do that. So 1. And 1. No, this is gonna be too... Let's forget about that. We'll just try to figure it out like we're big boys. So I ended up passing not a number to console.log for some reason. Let's work our way back from this. Robbers.length -1 ends up being not a number. It seems really weird to me. Okay, let's start by getting an idea of what we're putting in that robbers thing array. 1 empty item. So, obviously, we're doing something wrong here. What if I was just to do that? What do we get? Same thing, right? 4 empty items, okay. So that's cool. But wouldn't that work? Like, if I was to do equal returns 1. Is that a problem with the fact that we're using 0 or something? No, it's still if I was to map foo? Don't care about that for now. Still an empty item. Okay. Hmm. Pretty sure there's a way in JavaScript to instantiate a new array of a certain length and shove something in every single element. Array of, what is that? Method creates a new array instance from a variable number of arguments, regardless of number of type of the arguments. Between array of and the array constructors is the handling of integers arguments. Array of 7 creates an array with a single element, 7, whereas array 7 creates an empty array with the length property of 7. Note, this implies an array of 7 empty slots, not slots with actual undefined values. Right. Methods, accessor, let's do a quick search here. JavaScript, initialize array with values. The fill method modifies all the elements of an array from a start index to an index. Wow. How do I not know about the fill method? I've never. Must be a new one. When was it introduced? Standard. What? So if I was to do simply new array dot fill, look at that. Fill 0, start number, end number. This should just fill the entire thing with zeros. Never even heard of that method before. There we go, that works. Should have 4 of them, yeah. Huh, useful. Love learning stuff like that. Okay. So now, that should take care of a not a number problem. Getting that. This is good. This is not good. Oh, I so wished that it was going to work. Oh. I think it's just a sorting problem. So, what am I getting? The biggest one? I should be getting the smallest one, maybe? If it's not being sorted properly. Still, what? How can I get the same answer? Yeah, no. We need this. Now, let's see. We're good here, we're good there, we're not good here. What seems to be the matter? Why? How about this one here? No. We're way off. I thought for sure we had this right. Yeah, we're really gonna need to debug. So let's hunker down and do it. Which one are we trying to do here? This one. Let's just save this. Copy it, I mean. We need to go in here. So this will be 2. This will be 4. Now, let's just forget about that. And simply do actually, this might be easier. No, it won't. Let's go back to the original plan and just fill this up with, I'm actually gonna make another one for debugging purposes. Yeah, I really should be doing all this in my, not in the build file, but in here. That. Simple enough. Okay. That. Const vaults. It's going to be an array of C3 N and then just copy this C3 N2 C4 C4. It's gonna blow. And then same thing. Okay. Don't need you for this exercise. Thank you. Right. Debug. Alright, so it seems to have run. Let's see if we can put a breakpoint somewhere. And let's see. What are we particularly interested in? This is our main loop here. This is what we need to look at. About this here. Robbers. Okay, so what do we got? Expression to watch. No, I should learn how to use this thing. But for now, we're interested in vaults combinations. So vaults combination now has only the two last one left, 6250, 6250. For each, then we're adding this to robbers, so that's what we're interested in. Robbers has 250 and 500. Okay. And then, what is the solution we're supposed to get here? 1125. $11.25. Does that make sense? How do we get to 11.25 when our vault combination, the last two, are 6250? Does that mean that our get combinations formula has a problem? It would seem like it might. Rats. Yikes. If that's the case, we are not out of the woods. I don't see... expected 11.25. 4 and 0. 4 and 0. I think the 0's probably throwing off the calculation here. Right? If we have 4 combinations of 4 characters and 0 of them are digits, then they're only the vowels kind. And like we said before, we have 5 vowels, so it would be 5 times 5 times 5 times 5. Giving us 5 times 5 is 25, times 5 is 125, times 5 is 600 and something, whatever. So we're far from our 6,000. Oh, I think I know what the problem is. Hold on. Let's go back to our main here. The problem is, let's stop the debugger for now. The problem has to do with this. So, if I is smaller than vaults.n, and vaults.n is 0, we're multiplying, but yeah, okay. Oh, that's interesting. That is an interesting dilemma. Just going to solve this here very crudely by saying that if C is equal to 0, no, not C, N. If N, what, can I find N? It's right there. How can you not find N? Oh, vault. Oh boy. This puzzle is getting to me. If vault.n is equal to 0, then we want a special case of this thing here. We want this to be 1. Then once you're done with that, just return a total and forget about this last part here. Right? We good? Totally confusing, but I think that's going to take care of it. Nope, not quite, but we're closer to something reasonable. So let's debug this again. $12.50. And what are we saying here? $11.25. $11.25. So obviously, it's still not correct. It should be even smaller than that. Okay, okay. Let's take a look at this here. Oh boy, gotta go in 10 minutes. I don't think I'll have time to finish this. So 3 in 1. How's it handling this? Let's figure. So yep, okay. So you're going for I 1. So we get our 10, that's good. N is 0, this is what we need to wait. Oh yeah, and it was equal to 1, so we're good. That's what we want. Okay, so then we take 10 times the number of vowels, so that's 5, we should get 50, yeah. Then we got 2 more vowels, so we take 50 times 5, right? Yeah, get to 250. No. Yeah, that's right, okay. And then we do it once more. Oh no, we don't. Right, we had done it. So good. Return value 250. Okay. We're good. Next one. We should get 10. Then do it again. 10 times 10, 100. Okay. Then we're left with 1 vowel. Did a character, so 100 times 5, and we should end up with 500. Yeah, then this is where it gets, this is where it gets interesting. Because technically it should only give us, what was it? So there's 4 vowels, so 5 times 5 times 5 times 5, 625. What are we going to end up with? Oh, we're still catching a 10 here. If I is smaller than vault.n, oh, we haven't. Oh, but we are starting with a total of. Oh, okay. That's what we need to get rid of. Okay. So let's see. If vault this blah blah blah, then we just want our total to also be 0. So does that make sense? Nope, that won't work. So we need our total to be number of vowels. That's right. Let's try that. See what happens. Yes. Victory. So let's get rid of this. Get rid of that. Console log out this. Oh, what am I saying? Comment out this. Like that. Let's try running all our tests. Man. Ooh. Well, we're getting there. Big heist. What does that look like? Oh, man. There's 5 robbers, 20 vaults. A bunch of different situations here. What could be going wrong here? It's going to be hard to debug because I really feel like we've got this right now, don't we? So what could the problem be? Some sorting problem, maybe? Let's just do a console error of robbers. See if by chance our answer is in there somewhere. It is. Oh no, it's not. We're expecting this one here. 6515625. 515625. Looks to me like this is the closest one, but instead we have 6315625. So something doesn't work somewhere in there, but I'm out of time, unfortunately. I don't feel like this is, you know, an easy puzzle, but I might be going about it the wrong way. Must be some math formula or something I can be using. So, anyways, I guess I will finish solving this some other time. Thanks for watching this. Thanks for sticking around. I'll see you tomorrow for another live coding Twitch stream at 9 a.m. Eastern Daylight Savings Time. In the meantime, take care.